All right, so yesterday we found the roots and zeros and we were using synthetic substitution. Today we're going to be writing polynomials. That's going to be our main goal. So we're going to write polynomials to fit a given graph, like in example 1, and then we're going to write simplest polynomials when you are given the zeros. So I'm asking you to recall, how do you write the 0 of 1 as a factor? So a lot of times we've been solving, right? When you're solving, you end up with x is equal to 1, but before you get to x equals 1, we were factoring. So if you write this as a factor, it would be x what? What would give you the answer of 1? You have to have something with it. Remember, we set factors equal to 0 and solve. So if you were solving and you wanted to get 1, what would this be? Minus 1, right? Because if you had x minus 1 equal to 0, you'd add 1 over the line. Okay, so this is the factor form, and then this would be the 0. So if you had negative 1 as a 0, how would we write that as a factor? X plus 1. And if you had 0, it would be, well, even if you had x minus 0, what would you get? You just get x, right? So if it's 0, you can just write it as x. So in general, your factor form is going to be x minus a, where a is your 0. Okay, where a is a 0. Okay, so if your 0 is 1, it's x minus 1. If your 0 is negative 1, it's x minus negative 1. And how do we simplify minus a negative? Plus. So that's why this one is plus and not minus, because we simplified it. Okay? All right, so for example 1, we're going to write a polynomial that could be represented, this should say by the graph below. Okay, so the first thing we're going to do is we're going to pick out our x-intercepts from the graph. So I want you guys to find those and then just write them here. Okay, pick out your x-intercepts from the graph, write them down. Okay, so what are your x-intercepts? There's 3 of them. Close? Yep, negative 1, negative 2, negative 3. Good. Okay, so those are your x-intercepts. So when we write them in factor form, okay, we would have x plus 1, x plus 2, x plus 3. Okay, so to find a polynomial, what we're going to do is we're going to multiply that out. And when we multiply, we're using FOIL and the distributive property. Okay, so when you multiply, you are using FOIL and the distributive property here. And you can multiply these in any order. So if you want to do the first 2, you can. If you want to start with the last 2, you can. I always like to FOIL the last 2 together so that I can distribute the front one. So if you FOIL, you'll get x squared plus 2x plus 3x is plus 5x. 2 times 3 is 6. This x plus 1 in front still needs to be multiplied, so we're just going to distribute. Okay, so we're going to distribute x to everything. So we'll have x cubed plus 5x squared plus 6x. And then what else do I have to distribute? The 1. We distribute the 1 to everything. When you guys distribute the 1, can you guys line up your like terms so that we can add straight down? Did we already do it? Don't wait for me to do it. I want you to do it. Okay, so 1 times x squared is x squared. 1 times 5x is 5x. And 1 times 6 is 6. So then we're going to add straight down. Okay, and then since we're making a polynomial, we can call it f of x, we can call it p of x. Okay, you can pick whatever letter you want of x. Okay, and that is your polynomial function. Okay, so we're writing a polynomial. All right, now yesterday we learned about some root theorems. So we talked about the complex conjugate. If you have a plus bi as a 0, then a minus bi had to be a 0. And the same thing was true if you had irrational roots. So if you have a plus b root c, then a minus b root c is also a root. Can you guys think about why those two specifically, imaginary roots and irrational roots, why do those come in pairs? Yeah, you get the plus minus that happens whenever you do what? Square root. So both of those are generated from square roots, which is why they have to come in a pair. Okay, and it's not with any type of roots, because if you take a cube root, those do not come in pairs. This is a square root. So why do you think this is? It's because both imaginary and irrational roots are generated from square roots. Both imaginary and irrational roots are generated from square roots, which result in both a positive and negative solution. Okay, so you have the plus or minus whenever you do the square root. Okay, they're called imaginary and irrational roots. Okay, and they have both the positive and the negative solutions there. Okay, so what we're going to do for example 2 is we're going to write the simplest polynomial function with the given zeros. Okay, so when it says the simplest, it means you're trying to do that with the least degree. And they might give you all the zeros, or they might just give you some of the zeros. So we're going to have to use these rules to help us with that. Okay, so for A, your given zeros are 0, -2, and 3i. 0, -2, and 3i. So the first thing I like to do is list what all of my zeros are. So they give me 0. I know that has to be a 0. Is that imaginary or irrational? Right. It's rational, right? So it's not irrational, it's not imaginary, so there's no pair. -2. Okay, -2, not imaginary, not irrational. So just because -2 is a root doesn't mean 2 has to be a root. Okay, but if you have 3i, what else has to be a root? -3i. So if it's imaginary, you've got to put its pair in there. So you need to put that away and focus on this. Okay, so once you have all of your zeros, you're going to write that in factored form. Okay, so your zeros, there should be 4 of them based on our root theorems, which means your degree is 4. That means your final polynomial should have x to the power of 4. Okay? So what we're going to do is we're going to write this in factored form. And some of you could probably already do some of your factors without me. Just remember it's in your x minus a. We have your x minus a value. Okay, so if you have 0, remember we said that could just be x. If you have -2, that's x minus negative 2 or x plus 2. Okay, and then if you have 3i, it's x minus 3i. And if you have negative 3i, x minus a negative is going to be plus a positive. So when you are going to FOIL these, FOIL and the distributive property, you always want to FOIL your complex roots together first. This is going to make the process a lot easier. So always FOIL your complex roots together first. And then remember, when we have imaginary terms, sometimes you're going to get an I squared, and we plug in negative 1 for I squared whenever that happens. Okay? So we're going to FOIL the two complex conjugates together first. All right, so we're going to multiply x by x to get x squared. Now, what happens in the middle and the outside should always happen when you have complex conjugates. If I do negative 3i times x, I get negative 3ix, and then x times 3i is positive 3ix, okay, and you get 0. So it cancels out. That should always happen. You do not have to write that down. Like I said, it's always going to happen. It's a special pattern because really you have the difference of two perfect squares here, right? So what's going to happen is you have minus negative 3 times 3 is 9, and then you will have I squared. Okay, so you don't have to write this like when you're doing this out on your homework. I just want you to see what's going to happen every single time. What I do want you to show is what you plug in for I squared. So I understand you probably don't want to write everything down again, so it's fine if you just substitute in the negative 1. And a negative 9 times a negative 1 is going to be positive 9. Great. All right, and then we are also going to distribute here. So we're going to distribute x to x plus 2. That's going to give you x squared plus 2x. So x times x is x squared, x times 2 is 2x, and then we're just going to bring this down so we can multiply those together. So we're going to distribute x squared. Well, really, these are binomials, so you can FOIL. So I want you to FOIL that and then write the polynomial in standard form. So if you're writing it in standard form, your exponents go from greatest to least. Okay, so you can FOIL those. I'll give you a minute to do that. So you guys remember I like to FEAL, and it works out pretty nicely in this one. X squared times x squared is x to the 4th. If I do the inside, I'll get 2x cubed. The outside is 9x squared plus 18x, and then I do have that in standard form. So f of x equals x to the 4th plus 2x cubed minus 9x squared plus 18x. That should be your final answer there. Okay, so make sure you flip-flop those if you need to so that it is in standard form. All right, any questions for me on the first page?
For the, is it true for, like, fourth roots?
Yes, it's true for any, yes, for any even root. Yep, you'll only have square roots in this. Yeah. All right, so the other type of zero we're going to encounter that we haven't seen yet is a binomial zero. we've actually had those as zeros, right? We found those as zeros when we're using the quadratic formula. And when we have those and we're making the polynomial ourselves, we have to distribute the negative, and we're going to have to regroup some terms. So I remember that when I have a binomial, I have to use brackets. So I like alliteration. So binomials need brackets. Okay, so when we set this up, we are going to have some brackets and then parentheses inside those. So we're going to start the same way, where the first thing we're going to do is we're going to list our zeros. So they give us 5. Does 5 need -5 with it, or is it fine by itself? Fine by itself. Okay, only ones that need the partners are imaginary and square roots. So here we have 1 minus root 5. So does that need a partner with it? Yes, has to have 1 plus root 5. So based on this, we know that the degree is going to be 3. That means your final answer should be x cubed, okay? Okay, so then in step 2, we're going to write this in factor form. Remember, factor form is based on x minus a, where a is your 0, okay? So if you have 5, it's just x minus 5. That's your factor form. And then for the binomials, we're going to put these inside brackets because you have x minus, and then the binomial has to go inside a parenthesis. The reason why is because we have to remember to distribute that negative. So if you look here, this is my value. I'm putting that inside my parenthesis, and it's just x minus. Same thing for the next one. It's x minus, and then here I have 1 plus root 5. Okay, so every single one of these is x minus a. X minus 5, x minus 1 minus root 5, x minus 1 plus root 5. Okay, now once you have your factored form, now we can distribute the negative and regroup. This is going to make it a little simpler when you have to multiply. So when you distribute the negative, a negative times 1 is -1. What happens if I have a negative times a negative? Comes plus. Yeah. Okay, do you think you could distribute the negative for this one and write it down? Okay. It's really just different grouping symbols. So sometimes you'll see the double parentheses, which is fine. Or other times it'll be like a parenthesis, then a bracket. And then sometimes it'll be like the fancy brackets after that. It's just a system to help keep it more organized so there's not a bunch of parentheses there. Yeah. Yes. Yeah. It is to make it a little easier to read. Okay, so here you have the -1 and then the minus root 5. What we're going to regroup is the x minus 1 and the x minus 1. So you're regrouping the part that is not irrational, or in some cases it's not imaginary, and they should be the same. See how this is x minus 1 and this is x minus 1? The reason why they show you how to do the regrouping is because then you can FOIL this entire thing, because you can think of this as a binomial. So if you're doing FOIL and you do first term times the first term, this is your first term. So you're multiplying x minus 1 times x minus 1, which is just going to be x minus 1 to the power of 2. So think of these as your first terms. First times first is x minus 1 squared. Okay? Now again, the middle isn't something that I'm going to have you write down every time. I just want you to see what's happening here so you understand how the pattern works. So on the inside, you'd have root 5 times x minus 1. On the outside, you'd have negative root 5 times x minus 1. So together, when you add them, you get 0. So that's why you don't have to write it down every time. because with conjugates, they should always have an inside and an outside product of, well, the product and then the sum that's equal to 0. And then the last one, root 5 times root 5. Do we know what root 5 times root 5 is? 5, because it's the square root of 25, which simplifies to 5. A positive times a negative is a negative. Actually, I usually keep my brackets in this step too. Okay, so x minus 1 squared. Do not make the mistake of making this x squared plus 1. We've done a lot of work with that foiling, right? And we know that x minus 1 squared means x minus 1 times x minus 1, right? So when you FOIL that out, it's x squared minus what? 2x, yep, plus 1. And then this minus 5, you still have that. And then we're going to simplify it one more time to combine our like terms. Okay, so look at what we made here. Do you guys see this is a quadratic trinomial? So if we were solving this, we would solve it with the quadratic formula, and our answers would be 1 minus root 5 and 1 plus root 5. Okay, so sometimes if I'm like making a test or a quiz and I'm like, oh, I want to have something that has a 0, I could do this to create a polynomial that has the 0 that I wanted. Cool stuff. Okay, so then don't forget about your x minus 5 here. Okay, so your x minus 5 still has to be multiplied by this. Okay, so we can just drop it down, and now we're ready to distribute. Okay, so we're going to multiply everything in the parentheses by x. So we get x cubed minus 2x squared minus 4x. And then when you guys distribute everything by negative 5, and then line up your like terms. Done that already? Okay, and then you can check yours with mine to make sure we got the same thing. Okay, so our polynomial f of x is equal to x cubed minus 7x squared plus 6x plus 20. So we said the degree was 3. Your degree is going to be 3 here. Okay? Okay, so for C, we're going to start again by finding our zeros. So if you have negative 2i, does that have a partner? Yes. You have 1 plus root 2, 1 minus root 2 has got to be with it. Okay, so why don't you see if you can just set up the factored form, the first step, where you're putting in the parentheses there. Okay, so for your factored form, you have the minus 2i first. So I made mine x plus 2i and then x minus 2i. It honestly doesn't matter which one is first and which one is second. So the only reason I put that first is because I had the negative 2i listed first, but it's not going to make a difference. And then I have x minus 1 plus root 2. And then again, you need x minus, and then it's 1 minus root 2. Okay, and then we're going to distribute. So we have x minus 1 minus root 2, x minus 1 plus root 2. Okay, and then, yes, these two groupings should be the same every single time. Alright, so let me kind of FOIL that. So first times first. Okay, so x minus 1 times x minus 1. Right, that is x minus 1 squared. What's root 2 times root 2? No?
2.
Yep. Because root 2 times root 2 is like the square root of 4. When you have a negative times a positive, this is going to be a negative. Square root of 4, we know, simplifies to 2. So you can just think of it as root 2 times root 2 is 2. And then we're going to simplify this. X minus 1 squared, we actually did in the last one, so it's x squared minus 2x plus 1. And then don't forget, you have to do this before you can combine it with anything else. Okay, so then we're going to FOIL here. Okay, so go ahead and FOIL that and see if you can simplify. Okay, so x times x is x squared. The inside and the outside are going to cancel. 2i times negative 2i is negative 4i squared. And I want to see this step where you're plugging it in. You'll get x squared plus 4. So that's what you're going to end up multiplying by the x squared minus 2x minus 1. Okay, so if you distribute x squared to everything, it becomes x to the 4th minus 2x cubed minus x squared. Okay, and then distribute the 4, let's line up the terms. So 4 times x squared is 4x squared minus 8x minus 4. Negative 1 plus 4 is going to be 3. Nothing else has our like term. And I had 4 zeros, so my degree should be 4. And I have x to the 4, so that worked out. I have 4 zeros there. Okay, so then your assignment, like I said, I'm going to let you work on that in class. It's the 5.5 K2 worksheet. Okay, and you should be able to get that done in class.